Assalamualaikum and good days to the lecturer and my fellow friends. Today we are from Group 3 going to present a journal club with a title Interaction between cigarette smoking and fine particulate matter in the risk of lung cancer mortality in Cancer Prevention Study 2. Before we proceed, let's get to know with my group members. They are Alif Azhan bin Jamunir, Nur Alya Izzati binti Jeffrey and me myself Nur Syafinaz Izwani binti Mahazi. The article credit to author Michelle C. Turner, Aaron Cohen, Michael Jarrett, Susan M. Getcher, W. Ryan Deaver and others as stated. With correspondence to Dr. Michelle C. Turner that is from McLuhan Center of Population Health Risk Assessment, University of Ottawa. This article was initially submitted 30 January 2014 and accepted for publication 29 April 2014. The content that we will talk today is Introduction, Method of Study, Result and Data Analysis, and the last one is Conclusion. Let's start with the introduction. The aim of the study to examine interaction on additive scale between two major lung cancer risk factors, which are cigarette smoking and particulate matter 2.5 exposure in Cancer Prevention Study 2. Did you know International Agency for Research on Cancer recently had classified the outdoor air pollution and airborne particulate matter as carcinogen to humans, increasing the long-term exposure to ambient particulate matter with an aerodynamic diameter less than or equal to 2.5 micrometer, or also known as particulate matter 2.5, raise the risk of lung cancer. The reduction in cigarette smoking will achieve the greatest impact in lung cancer rate, but together with tobacco control and air quality management, it will exceed the expectation of reducing the exposure to either risk factor alone.
Hi everyone, I am Nur Alya Izzati and I'm going to present about the methods of our topic. Let's go! The first method is about the study population. CEPS2, or known as the Cancer Prevention Study 2, is a prospective cohort study of nearly 1.2 million participants enrolled by over 77,000 of volunteers in 1982. Most of the participants coming from 50 states in the US, including District of Columbia and also Puerto Rico. To be included in this study, the participants need to be at least 30 years old and have at least one family member that is 45 years old and above. The participants were given a questionnaire to obtain their data such as their lifestyle, medical status and also the place of residency. There were also follow-up for participants' vital status that is conducted for every 2 years, where the information was obtained from the participant itself until a computerized linkage were used to obtain the participants' data in 1989. Of the 1.2 million participants, there is only 429,406 participants were retained after they excluded some participants that have invalid address information, missing data on vital status, individual level covarieties of interest, and also former cigarette smoker, which give a result of 1,921 lung cancer deaths were observed. The second method is regarding the exposure to PM2.5. For your information, PM2.5 is a type of particulate matter that is less than or equal to 2.5 micrometer. Can you imagine how small the particles are? So before we go into deeper, as you can see from the slide, BME is a method that is used for spatial analysis and mapping data, while LUR is an algorithm used for analyzing pollution. For the model of this exposure, a national level hybrid land use regression LUR and Bayesian maximum entropy BME interpolation model were used to link the ambient of particulate matter 2.5 concentrations to the home address of the Cancer Prevention Study 2 participant enrolled back in the 1982. And for the data, in the first stage, the LUR model were used to predict the particulate matter of 2.5 concentration based on two variables, which are the vehicular traffic at 1000 meter and also the green space at 100 meter cubic. While in the second stage, a BME interpolation model was used to capture the residual spatiotemporal variation in the PM2.5 concentrations. So the monthly data of particulate matter of 2.5 were available from 1999 up till the year of 2008 for about 1,464 monitoring locations. As a result, the average value of PM2.5 exposure concentrations were obtained, and it was ranged from 1.38 to 27.94 microgram per meter cubic with a mean of 12.61. Last but not least is the statistical analysis. To examine the links between cigarette smoking and lung cancer mortality, the Cox proportional hazard regression models were used, and at enrollment, the dichotomous indicators for cigarette smoking, which are the current smoker versus never smoker and PM2.5 exposure, were evaluated. Besides, the individual level risk factors such as education, marital status, body mass index, and alcohol consumptions were used to calculate the estimated hazard ratios and 95% of CI, or the confidence interval. For the additive scale, the relative access risk due to interaction RARI and also the attributable proportion due to interactions AP and synergy index S were used to assess the effect modification. The RARI and AP value of 0 and also the S value of 1 is equal to no interaction had occurred. And lastly, on the multiplicative scale, the interaction terms for interaction between cigarette smoking and particulate matter of 2.5 concentrations were entered into the proportional hazards of regression models. Thank you.
Hi, I'm Alif. I will explain about the data and result for method being used to examine the interaction on the adaptive scale between two major lung cancer, which is cigarette smoking status and PM2.5 exposure in Cancer Prevention Study 2. The result of the data, the majority participant is 40 until 69 years and enrollment were female and had attained a level of education greater than high school. The variation lung cancer mortality rate was based on the cigarette smoking status and PM2.5 exposure, which is we can look at the table 1. The difference in the lung cancer mortality between never cigarette smoker and current cigarette smoker was greater with higher PM2.5 concentration. When we look through the table 2, the hazard ratio for the current cigarette smokers as compared with the never smokers range from 13.53 with a 95% of confidence interval, which 10.21, 17.93 to 14.48 with a 95% of confidence interval, which 11.31, 18.52 among the subjects exposed to low PM2.5 concentration. Moreover, hazard ratio for the high PM2.5 concentration versus low concentration was ranged from 1.28 to 1.41 among never smokers. Besides that, the hazard ratio for the current cigarette smokers was exposed to high level of PM2.5 when compared with the never smokers exposed to low level of PM2.5 was ranged from the 15.0 to 16.48. From the method being used, the AP range, or known as the attributable proportion, can be decided from 0.04 to 0.14, and this value can be calculated with the formula given. The S range, or known as the synergy index, can be calculated from the formula given, and it can be decided from 0.04 to 0.14. The estimation of RARI, or known as the relative access risk, can be ranged from the 0.66 to 2.19, and this value can be calculated with the formula given. This value actually depending on the categorical indicator of cigarette smoking and PM2.5 concentration. This value actually indicating small increases in risk factor among persons with both exposure compared with that expected based on the sum of the individual exposure alone. In sensitivity analysis, the RARI APS also generally increase when using the 25th and 75th percentile as a cut point for PM2.5 in men. The value of RARI is 4.64, AP 0.17, S is 1.22. The participants reporting less than 3 hours of daily exposure to secondhand tobacco smoke, and the value for the RARI is 3.09, AP 0.18, S 1.24. Besides that, the heavy cigarette smoker which have a greater than or equal 20 pack per year, the value known for the RARI is 2.68, AP 0.14, S 1.17. On the multiplicative scale, the estimate of interaction range from 0.81 to 0.93. This range actually indicating a joint effect somewhat smaller than the product of the individual exposure, but these estimates were precise based on the table 2. The similar result also were obtained when adjusting for mean county level residential radon concentration or 1980 socio-demographic ecological covariates.
From the article, we can conclude that combined effect of lung cancer mortality among cigarette smokers with high particulate matter 2.5 exposure result in 2.2 times greater than the result of cigarette smoking and particulate matter 2.5 alone. Next, approximately 14% of lung cancer mortality among cigarette smokers with high particulate matter 2.5 exposure may be due to the interaction of these two factors. Apart from that, cumulative exposure to tobacco smoke can be estimated by questionnaire, but lifetime exposure toward the air pollution cannot be predicted from the cancer prevention study to data. Last but not least, lung cancer risk is determined by many carcinogenic substances carried by the particles, which may have various levels of toxicity, different timing of exposure, and exposure level. Thank you for your time. That's all from our group.